So in the last class, we are discussing about the deep learning concepts where we have discussed about the activation functions. Now, let us have a small recap, whatever we have discussed. So we are having the neural network where a neural network is a combination of multiple neurons connected to each other. Neural networks means multiple neurons connected to each other. A neural network means connected each other. Each of them connected to each. So now we are having some neurons. Okay, some input neurons we are having. Okay, let us consider this one as the input layer. Right? Now we are having some hidden layer. Let us consider as a hidden layer. Now this one is the output layer. Okay, where this is the output layer. And connection between them. The connection between them within this. Okay, this is called as a neural network. Where this neural network we are having with respect to each neuron will take the information and it will process the information and it will pass the information. Okay, for example, this neuron. What is this neuron means? This neuron, whatever the neuron was connected to which neurons it has connected, it is going to select the weights of that particular. For example, here W1, W2, W3, W4, W5, W6, W7, W8. We are having total 8 connections are there. So 8 weights we are going to randomly initialize. The 8 weights we are going to randomly initialize. Now, first, when you have initialized and you have connected the neuron like that, automatically what happens means once the input was sent into this one, once the data was fitted, once the information was sent, that is X1, this is X2, and here X3, the information was sent. Now, this neuron, what is this neuron means? This neuron was connected to W1 into X1 plus this neuron was connected to W3 into X2. Next, this neuron was connected to W5 into X3 plus B. Whatever this neuron was connected to which particular neurons, that particular neurons, it is going to do the summation of sigma Wi Xi plus B. This neuron will have this equation, whereas this neuron will have W2 into X2, X1 plus W4 into X2 plus W6 into X3 plus B. This is the this one. Now, first it is going to calculate the sigma Wi Xi plus B. Whatever the sigma Wi Xi plus B is there, this is going to calculate the sigma Wi Xi plus B. Followed by, what is the next one? Activation function. So now whatever the activation function, the activation functions are represented by pi. This is the representation of activation function. In neural networks, the representation of activation function is given as pi. Okay, this is the activation function representation. Now, what it is going to do? This is going to be converted based on the activation function. Whatever the activation function you have selected. Now, whatever the activation function you are selecting for the particular neuron, that entire layer you have to select the one activation function. You can't give the separately the activation functions for the individual neurons. For the entire layer, you have to give any one activation function as per your choice. There is no fixed rule for the hidden layers. For the hidden layers, there is no rule. For output layer, there is a rule. But for hidden layers, there is no rule. So you can select as per your choice. 90% of the cases will go with the ReLU. Okay, ReLU as the activation function. But there is no rule for the activation function of the hidden layer. Now, whatever the hidden layer is there, for example, let us assume I'm having the ReLU as the activation function, and after the activation function, it has given some output of 1. Let us keep this one as 1, O1. The output of this one is O2. Now, for this neuron, how it is going to calculate? W7 into O1 plus W8 into O2 plus B. Okay, for this neuron, these are the two connections are there. So, for this neuron, it is going to connect in this way. Okay, so sigma Wxi plus B means whatever the neurons it has got connected, it is going to take that values. Is that clear? So for this neuron, these three are the connections. Which three are connected to this particular neuron? Those weights it is going to consider. For this neuron, what three weights are connected? That one it is going to consider into the input. Similarly, the weights into input of this one is, for this input is, output of this one is the input for this one. So which is nothing but O1 is the output of this one, which is the input for this neuron. For this neuron, this is the input. Similarly, how we have considered X1 as the input for this one, O1 is the input of this neuron. So it is going to consider the O1 value, O1 into W7, and it is going to calculate the sigma Wi Xi plus D. Now here, whatever the different types of activation functions we are having, different types of activation functions. As we have seen in the different types of activation functions in the last class, different types of activation functions are: one, step function. This step function is also called as threshold function. This step function is also called as threshold function, where it is going to convert, if the value is greater than or equal to 0 means it will convert to 1. If the value is greater than 0, it will convert to 1. If the value is less than or equal to 0, it will convert to 0, simple 0. Equal to 0 also, output is 0 only, right? So if the value is greater than 0, it is converting to 1. It will convert to this in the step function. Whereas second, we have seen with respect to second one called as sigmoid function. In the sigmoid function, where it is going to convert based on the p value. P is equal to 1 divided by 1 plus e to the power of minus y. If the p value is greater than or equal to 0.5, it is going to convert to class 1. If the value is less than 0.5, it is going to convert to class 0. Right? This whatever we have observed in the logistic regression, the same thing. Next one is, third one is, we are having is called as tan h function. Tan h function, where the values are converted between 1 plus 1 minus e to the power of minus 2y divided by 1 plus e to the power of minus 2y. It is going to take the values between minus 1 to plus 1. It will get to only minus 1 to plus 1. Whatever the value it is having, it will send that same value output. It will not convert. It will just send whatever the value it has got, it will send. That is from 0 to 1. So here, whatever the p values are there, this is the logistic regression. But in the neural networks, whatever the p value you have got, it will send the same p value. It is not going to change to 0 to 1. The range is 0 to 1. Range is 0 to 1. Not only 0, 1, 0 to 1. Here only 0 and 1. Only two options are there. Either 0 or 1. This is the range. Here the range is 0 to 1. Here the range is minus 1 to plus 1. Next we are having fourth one called as a ReLU function, where ReLU is going to take negative values. If the y value is less than 0, it is converting to 0. If the y value is greater than or equal to 0, whatever the value, it is going to consider the same value. So the range is from 0 to y value, anything. So infinite. It is going to be infinite. So this is the range of ReLU. Next, we have seen with respect to the leaky ReLU. Leaky ReLU function. So this leaky ReLU function, whatever the lesser value is there, y less than 0, it is going to convert instead of that minus 0.00001 into y, so that some value will be reduced. And we greater than or equal to y, this one means whatever the y. So the range is going to be minus infinite to plus infinity, minus infinity to plus infinity, right? So these are the things which we have discussed in the last class, right? Now here we have seen with respect to how we are going to convert with respect to activation functions. Done? Now, the various activation functions, whatever the activation functions we are having, the first activation function is threshold. The threshold value is, if the value is less than or equal to 0, it is converting to 0. If the value is greater than or equal to 0, it will convert to 1, right? So now we are going to get either the output as either 1 or 0. Only two options, either 0 or 1. If you take the graph, if you plot the graph between the values, you'll get all either zeros or one. This is the step function. This step function is also called as threshold function. Graph will be in this way. Second one is sigmoid function. Sigmoid function is whatever the value you have got, it is going to convert to equation where the values will be from 0 to 1. This is the sigmoid curve. Everyone knows. In the logistic regression, we have seen in the sigmoid equation. Next one is tan H. Now, wherever the tan H is there, tan H values lies between -1 to +1. Again, the values, just it is going to substitute the values here. Whatever the sigma wi xi plus b is there, that value will be substituted here and it is going to calculate the output, right? So on the x-axis here, whatever the x is, they don't consider x. This is nothing but sigma wi xi plus b. Whatever the value you have got, that value this is. Okay. So that value you are considering on this one and you'll get the -1 to +1 range of. Next one is ReLU. ReLU means the negative values will be converted to 0. All the negative values will be converted to 0. Positive values linear. So the graph will be like this. All the positive values, whatever the positive value, if you have got 1 as the output means 1 only. 2 as the output means 2 only. 3 as the output means 3 only. 4 as the output means 4 only. 500 as the output means 500 only. But whereas -1, it will be converted to 0. Right? Is that clear? The graphs are clear, or should you want me to explain in a detail? Just if you take this example, sigma wi xi plus b, what is the output? Sigma wi xi plus b some value versus output. Now, for example, let us take sigma wi xi plus b. Okay, you have got with respect to sigma wi xi plus, let us take this one. First, let us make a graph for ReLU. How to plot the ReLU graph. So you have got sigma wi xi plus b has some value. You tell me some value. Some value like 400. Whatever the value you have got, it is output also same. If the value is -200, 0. If the value is plus 9,000, 9,000. If the value is -40, 0. -248, 0. Just now you make a line plot for this, taking the x value of this one, y values as this one, and draw the line plot. Now what happens? Line plot means in terms of 400 comma 400. Wherever the y, if this one 400, 400. This is the point 1. -200 comma 0. Let us assume this is -200. 0 means this is the point. Plus 9,000 plus 9,000. Let us assume this is the 9,000. This is 9,000. Okay. Now this is -40. So -40, 0. -248 also 0. So minus values all, if you draw a line plot, all the negative values will come to 0. Okay. So let us take in a simple way, for your understanding easy way, instead of going with this much of big values. -5, 0, -4, 0, -3, 0, -2, 0, -1, 0, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Now draw the plot. That is -5 comma 0, -4 comma 0, -3 comma 0, -2 comma 0, -1 comma 0, 0 comma 0, 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5. If you draw a scatter plot, now line plot, now automatically this is the line, right? This is the ReLU graph. Is that clear now? Just you take some values like this and some value, whatever the output. So positive values, linear value. For 1, 1 only. For 2, 2 only. 3, 3 only. Just you keep it dots like this. For 4, 4 only. And you join them. Automatically you'll get a linear line only, right? Straight line only, right? Straight line is nothing but y is equal to x. mx plus p, where slope is 1, intercept is 0. If intercept is 0, the line passes through the origin automatically. Right? This equation is nothing but if your y value is greater than 0, then convert the y value is equal to 1 into x plus 0 is the backend code. Else, if y is less than or equal to 0, convert the y value to 0. That is the backend code of ReLU. Okay, what is this y means? Y is nothing but sigma wi xi plus b. If you write this one as y means y hat means y hat, z means z, whatever the notation. First step of the value, whatever you have got, that to be converted. Notation is as per your choice. In one books, one notation they have followed. There is no fixed notation to write. Because if I write y hat this one, then final output, what do I have to write? Final output also y hat only. This is y hat, final output also y hat means, again we will get confused. So choice is yours. You can write as per your choice. Write as z. If you feel it is as z, write z. If the z value is greater than 0, if the z, then convert the z value to x plus 1 into x plus 0. Z is equal to 1 into x plus 0. If the z value is less than 0, convert the z to exactly 0. Right? Now you have got the equation like this. Now same equation. Okay. Now it is, if it is ReLU, instead of ReLU, I am going with the Leaky ReLU. Okay, Leaky ReLU. Now what happens for the Leaky ReLU? Same, you have got outputs. Leaky ReLU, what happens? This is 0.000000 something, some value. This is 0.00004, 0.00003. 0 point. Positives only, negatives only. Whatever the sign is there, the same sign. It will just multiply into 0.000 something. Some negligible value we have to multiply. So the negligible value, I am considering the negligible value as 0.0405. My negligible value is 4 zeros. Minus 0.404. Minus 40.3. Minus 40.2. Minus 401. This is 0. This is 1, 2, 3, 4, 5. Positive values, no changes. Only negative values will be converted. Instead of 0, it is just multiplying into the 10 to the power of minus 5. Okay. Now just make a plot once again. Draw the plot. That is minus 5. Minus 5 versus this one. You will get negative. Minus 5 is this one. In the x-axis, minus 5. Y also negative only, right? Minus means this one. You will get with respect to minus 0.05 means almost close to your y-axis only, but negligible value. This one, this one, this one, this one, this one. So you are going to get this one in the negative direction. Very less values. Whereas positive direction, it is common. In the ReLU, whatever the positive is, the same thing will be there. Negative, instead of combining into a straight line, if you take a straight line like this on the y-axis, that is ReLU, if you have some values on some y-axis, y values, something you are having y means, then it is called as leaky ReLU. Okay, the graph of leaky ReLU, you can see like this, right? So these are the graphs: step function graph, sigmoid graph, tan H graph, ReLU graph, and leaky ReLU graph. Graphs are important, range is important, and types are important. Okay. So this range, once again, range is either 0 or 1. Range is between 0 to 1. Range is between minus 1 to plus 1. Range is between 0 to infinite. If 20,000 is their x value, y also 20,000 only will be there. 30,000 is there means y also 30,000. Whatever the y. So it is going to be 0 to infinite, between 0 to infinite. This is minus infinite to plus infinity. These are the ranges. Okay. In the interview, they are going to ask what are the different types of activation functions are available and what is the range of each activation function. Right. Now, next one is, question is, now for hidden layers, what activation function we have to use? What activation function we have to use? Activation functions, shortcut, we can write A by F. A by F means that is activation function me. No need to write every time activation function complete word. Shortcut is A by F. So what activation function we have to use? Okay, for hidden layers, what type of activation function we have to use? Means answer, no fix, nothing is fixed. No fixed answer is there for this. But generally, we select ReLU. Generally, we'll select ReLU as the activation function. There is no fixed answer. No fixed answer is there means what is the meaning? Means you have to do the hyperparameter tuning. Whenever there is no fixed answer, the meaning is hyperparameter tuning. For hidden layers, none of them is fixed. Already I have told you yesterday. Number of neurons are not fixed. Number of hidden layers are not fixed. What is the activation function is there? Not fixed. Nothing is fixed for the hidden layers. Hidden layer should be selected or not, only not fixed first. If you don't select the hidden layer also, it is called as perceptron model, right? Hidden layer is also not compulsory, right? Now, most of the cases will go with the ReLU. Why ReLU? Because it reduces the overfitting problem. Reduces the overfitting problem. How it will reduce? Because the negative values will be rectified. All negative values will be rectified. All the negative values will be rectified. So rectified means all the negative values, whichever the negative values neurons, whichever the bad neurons are there, that neurons will be automatically dropped. It will not consider those neurons. So automatically rectification is done. Right? Whenever the bad answer we are getting, automatically the rectification it is going to do. So that is the reason we'll go with the ReLU as the activation function. But at the same time, it is not compulsory. Right? Now, second question, question number 2. For output layer, what activation function I have to select? Here there is a rule. What activation function I have to select? We have to use. Once again, we have to use. Question is. Now answer is fixed answer is there. For regression, select ReLU. Compulsory. For regression, go with ReLU. For binary classification, go with either sigmoid or step function. Either sigmoid or step function. 99.9999999% sigmoid. In the very rare cases, step function also gives the better answers. Out of 10,000 data sets, one might give the step answer as the better answer. Maybe. Till now, I have not identified. We tried with step also, but never we have got the best answer in the step. Maybe we may get in the future. I don't know. But as of now, sigmoid is the best one. So blindly to say for binary classification, we have to go with the sigmoid. Okay. If you ask only one, no need to confuse yourself, miss sigmoid. Blindly go with the sigmoid. Right? For multi-class classification, in the output layer, the activation function we have to use is softmax. It is mandatory. This is mandatory, this is mandatory, this is mandatory. So in the output layer, activation functions are fixed, neurons are fixed, everything is fixed. Input also same. For input, number of neurons are fixed. No activation function for the input because it is not connected to anything. Which was connected, which is taking the information, it has to process. Input is not taking any information. Input is passing the information, but it is not taking the information. So there is no process to be done in the hidden in the input neuron. Right? Now, finally, so I'm writing once again. First neurons, 3 neurons I'm collecting. Okay. 2 neurons and 1 neuron. First, I'm going to select the weights I'm going to give the connections like this. First step is give the connections. Between what? Step number 1. What is the step number 1 means connect between the input layer and hidden layer. Step number 1. You have to connect between input layer and hidden layer. Step number 2. Assign the weights. Assign the weights. Some weights, some values for that. Assign the values for that. How to assign the values? That is randomly only, but there is rule also for that. Randomly only we are going to analyze, but within that also some rules are there. Not with respect as per your choice, some values are there. Right? But that too randomly. Now, after that, once you initialize the weights completed, now step number 3. Again, connect between the hidden layer with respect to the output layer. Connect. After connecting, now again you assign the weights. Whatever the weights are there, assign the weights. Next, here for this hidden layer, assign what is the activation function you want. ReLU. I'm going to assign the ReLU. Now here, what is the activation function you want? That depends upon the problem. Depends upon the problem. If my problem is TV, radio, newspaper, and says is the output. This is the example where I'm having TV, radio, newspaper, X1, X2, X3. Now here, automatically, since it is a regression problem, I'm going to assign for this one also a ReLU as the activation function. If it is a regression problem, automatically you have to assign ReLU. If it is not a regression problem, classification binary means go with sigmoid. If it is multi-class problem means go with softmax. I will show you 3 of them. 3 examples I will show you in the coding. How to select and how to assign, everything we'll discuss. Right? Now, next, once we have created the model, once the model was created and the weights are also assigned, now we are going to pass the information into this. Now information will be sent. Is that clear? Now information will be sent into this one. Now once the information is sent, already the weights are fixed. Now for example, here I have sent with 200, 400, 100, something. Already the weights are already fixed. Some values are already assigned. I have initialized randomly some values. Whatever the values, I have assigned something. Now it is going to calculate the first sigma wi xi plus b. First, it is going to calculate sigma wi xi plus b, this one. Here it is not going to do that one. Why it is not going to do? Because it is not connected to the previous one. This is connected. This is connected. This is not connected. This is connected and it is getting the information. Connected means it is getting the information from what are the 3 things it is getting the information? W1, W3 and W5. So with these 3, it is going to make the formula of W1 x1 plus W3 x2 plus W5 x3 plus b. Followed by, once this is calculated, now it is going to apply the ReLU as the activation function. After applying the ReLU, if it is, for example, you have got this value, total value as 400, something of 4000. Now output of this is, what is the output of this neuron? 400, 4000 only. Whatever the output is there, it is going to send the same because it is a ReLU. The same thing will be sent out of that and into that, right? If, for example, this is minus 4000, the output will be 0. After calculation, the output will be decided based on the activation function. Is that clear? Now, once the output is 0, assume output is 0. Now, this output is going to be multiplied with this one. For this neuron, sigma wi xi plus b. For this neuron, what is sigma wi xi plus b is nothing but W7 into output of this neuron. Let us take it as O1 plus W7 into W8 into O2. Output is O2 plus B. For example, this is 0 means 0 into W7, automatically 0 only, right? Means indirectly the neuron was dead. In that neuron, nothing information I'm getting outside. It is collecting the information, but it is not passing the information. The neuron was dead. taking the information, but it is not giving. It is processing, taking, everything is done, but it is not sharing that information to others. Right? Here also same. You are going to process this one, which is nothing but W2 into X1 plus W4 into X2 plus W6 into X3. And you are going to take the activation function for that. And whatever the output you have got, that is O2. Output of this one is O2. And this O2 will be shared to this neuron. And it is going to calculate. And according to that, it is also going to do the activation function. Is that clear? Now, okay, sir, fine. Everything is done. Neural network was designed. Now, questions are, how we are going to initialize the weights? Question number 1. Okay, weights are initialized and everything is calculated. Randomly weights are initialized means randomly the answer we are going to get. As the weight changes, automatically answer changes, right? Randomly some answer we are going to get. How that answer we are going to select? So here, let us assume TV, radio, newspaper example only. TV, radio, newspaper and says. Same thing. For this linear regression I have applied. Right? Now the same logic, what it is going to do, you know, here 3 neurons and 1 neuron. And only without hidden layer, directly I am taking the perceptron model only. Directly I am selecting the perceptron. There is no hidden layer. Now here it is X1, X2, X3, W1, W2, W3. Now W1, it is going to assign the values between some values. So how we are going to assign the random values? So how we are going to assign this one is, let us see this and we'll come back to again this one. So how we are going to assign the values means in this way. The weight initializations, we are having different formulas are there. What are the different formulas means? Options means one is called as uniform. The first option is called as uniform. Second option we are having Xavier uniform. Third one, Xavier normal. Fourth one, he int uniform. Fifth one, he int normal. Now, what is meant by uniform? Uniform means whatever the weights it is going to select, the weight should be selected between minus of square root of 1 divided by square root of n2 plus 1 divided by square root of 1. It should be between the range of this one. For example, let us take like this earlier example. Okay. Now here, how many total weights are there? Total weights, total, everything you have to include, everything, all the weights. For in the entire neural network, for example, 500 weights are there, assume. 500 also you have to include. 10,000 weights are there, 10,000 you have to include. 20,000 weights are there, 20,000 you have to include. Now it is going to get 3 weights. 3 weights are selected. 3 weights are selected randomly from minus 1 by square root of 3 to plus 1 by square root of 3, where 3 is the number of input features, not the weights. Where 3 is the number of input features. This is input features, number of input features. How many input features? In my case, 3 input features are there. Okay. So for example, here, one more neural network I'm drawing. Okay. 3 input features, hidden layer and output layer. How many total weights? 3 into 2, 6. This is 6. 2 into 1, 2. 6 plus 2. 8 weights. Total 8 weights are there. 8 weights are selected randomly between minus 1 by square root of 3 to plus 1 by square root of 3. Whatever the weights are there, that weights will be selected. No, sir, from here to here, I want to select only for this one also, you can select. These 6 neurons, whatever the 6 weights are there, these 6 weights you can select randomly between minus 1 to plus 1 by 3. 2 weights you can select based on the Xavier uniform. That is your choice. You can take like that. Right? So these 6 connections, what if I have given for this layer, I have written the word called as uniform. If I write the uniform word for this automatically in between 6 connections are there. These 6 weights are connected between minus 1 by square root of 3 to plus 1 by square root of 3. Is that clear? So if it is uniform means in this way it is going to select. If it is Xavier uniform, minus 1 by minus 6 to divide by number of input futures plus output future also you have to add. Not only input futures, output future also you have to add. 2 plus divide by square root of 1 by square root of 6 by input futures plus output futures. How many number of output futures you are having, right? You have to select 6 weights, 8 weights, or whatever the weights are there, number of weights, uniform distribution, which forms the uniform distribution. Means in the backend, it is going to apply np.random.uniform. This is the function it is going to apply in the backend. When you are asking normal, it is going to apply np.random.normal, and it is going to give whatever the range. Whatever the range is there, it is going to give that range. So here, for example, I have written, I want 100 weights. 100 weights between 5 to 6, which forms the uniform distribution. Uniform distribution means what it is going to do, it is going to select 10 weights between 5 to 5.1, 10 weights from 5.1 to 5.2, 10 weights from 5.2 to 5.3, 10 weights from 5.3 to 5.4, 10 weights from 5.5 to 5.5, 10 weights from 5.25 to 5.6, 10 weights between 5.6 to 5.7, 10 weights between 5.7 to 5.8, 10 weights between 5.98 to 5.9, 10 weights between 5.9 to 6.0. So equally, if you draw the histogram, it is going to form the uniform distribution between 5 to 6. Normal distribution means the same thing you are going to get between this. If you draw the histogram, it is going to have the bell curve. Center values will be the maximum. 5.4 and whatever these values are there, 5.5 to 5.6, these values will be the maximum when compared to 5.5 to 5.1. Right? So it has to form the uniform distribution or normal distribution. Xavier normal says that it has to form the normal distribution between this to this. Minimum value of this one to maximum value of this one. U means uniform distribution. It has to form the uniform distribution of weights. Whatever the number of weights you are selecting. Okay. For example, sir, let us take like this, sir. Earlier you have drawn some neural network now. So let us take a neural network and explain. Sir, this W1, W2, W3. Let us assume I have applied here uniform. Just I have written uniform. Now what is uniform is? Uniform distribution between minus 1 by input, number of input neurons. For this layer, how many input neurons are there? 3 input neurons. For this layer, input neurons are 3. For this layer, input neurons are 4 means 4. For this input, for this layer, entire layer, how many input neurons it is considering? It is considering with respect to 5 means 5, 10 means 10, whatever it is. So for example, I'm having with respect to 3 input neurons. So it is going to select between square root of minus 1 by 232 plus 1 by square root of 3. First, you have to calculate this value. You are going to calculate this value as minus 0.004 to plus 0.004. Assume. I have not calculated. Example I am writing. Okay. This is not the exact answer. Example. Right. So now here, whatever the values you have got, between these, you have to select 3 weights. Between this, you have to select 3 weights. Okay. Between this one only. Just how to select the 3 weights between this one. That too, uniform distribution it has to form. That too, it has to form the uniform distribution. Just it is applying the in the backend np.random.uniform. And it np.random.uniform minus 0.04 to plus 0.04 comma 3. 3 means 3 number of samples. It is going to select 3 samples. That 3 samples will be given as here the values. Whatever the values it has got, it will give. It is clear now? It is clear? Now, similarly, Xavier uniform. Xavier uniform is minus 6 by Input plus output. Output neurons also it has to calculate that whatever the layer it has connected, in that layer how many neurons are there, that one also it has to collect. Okay. And Xavier normal means from 0 to that value. So this is the range of the values. Okay. Now, once it is done, now let us see till now whatever we have discussed, how to create the neural network. Let us see how to create the neural network. Now for this data set, first I want to try the perceptron model. Question number 1, perceptron model. I want to try perceptron model. Question 2, I want to try with a neural network. Neural network with hidden layer 1, hidden layers is equal to 1 and neurons is equal to 4. 3, a neural network. I want to create a neural network with hidden layers, number of hidden layers is equal to 2 and neurons is equal to 3 in each. This is my requirement. How to create the models. So earlier in the machine learning, till now whatever in the machine learning, whatever the modeling we have done, modeling in ML, what we have done is just we have imported. For second one is we have saved the model, save as the model name, as some model name, some of the model name as per your choice, some name. And third one is model dot fit. We have done the fit. These are the 3 steps we have done in this one. But here import only remains same, fit remains same, but model is not fixed. Model is you have to select as per your requirement. You have to design your own neural network. Neural network is not fixed. We are not going to get the import ANN is not available. Import is available only TensorFlow, Keras is the libraries available. So directly the library, directly the ML ANN algorithm is not directly available. You can't import directly the ANN. ANN is not available as the algorithm because that is not fixed. So we have to create as per our requirements. For example, I want to create this one. Okay, a perceptron model with a perceptron model for TV, radio, newspaper, model number 1. Model number 1. Perceptron model. How many number of input layers? How many number of input layers will you have to take? 1 input layer. How many output layers? 1 output layer. How many hidden layers for perceptron? No hidden layer. 0 number of hidden layers. Within the input layer, how many number of neurons should be taken? 3, because here TV, radio, newspaper, 3 input values are there. So 3 input columns, only 3. Output 1. Why? Because it is a regression problem. For regression problem, only 1. Next, what you are going to do? Next one is you are going to connect. You are going to connect like this. Once you have connected, you are going to initialize the weights by using uniform or Xavier uniform, whatever it is. Generally, 99% of the cases we'll go with the uniform. So select the uniform. Once we have selected the uniform, next, after selecting uniform, what is the next step? For this one, you have to give some activation function as per your choice. Since it is a output layer, there is no choice. 100% we have to follow the rule only. For hidden layer, only choice is there. For output layer, no choice will be there. So now, what is the thing you have to give? ReLU. This is called as designing of the neural network. For this one, perceptron model, this is the design. Now I want one more neural network where 1 hidden layer with 4 neurons. Now once again, model number 2. If I want this one, how I have to design? How many number of input layers? 1. How many number of output layers? 1. Okay. Now first input layer, how many neurons I have to take in the input layer? 3. It is fixed. Okay. Hidden layers are requirement is 1. Within that 4 neurons. 1, 2, 3, 4. Next one is output layer. In the output layer, how many number of neurons? 1 neuron. Next, what you have to do? Give the connection. How many connections? These, how many values are there? That many neurons. Just multiply the input neurons into this one. Those many connections you are going to get. That is 3 into 4, 12 connections you are going to get. 12 weights you have to initialize. For this, how you are going to initialize the 12 weights? That is W1 to W12. How you are going to initialize? By using any kernel, any initializer like uniform or Xavier uniform or Hind uniform. For example, I am selecting uniform. Uniform I have selected. Now, after that, what is the activation function I have to give for this layer? ReLU. Hidden layer, ReLU. Now, again, you have to connect. For this, again, you have to select uniform and output is ReLU. This is the neural network for the second model. In this way, you are going to connect. Okay. So whatever the values are connected, it is going to calculate the sigma WXI plus B according to that. And later it is going to convert in the activation function. For this, whichever the weights are connected, that weights only it is going to multiply into that output values. Whatever the values it is having. Right? Similarly, this one, if you want to connect this one, again, 3 input layers, 3 neurons in the input layer and 2 hidden layers of each of 3. 3, 3. 1. Now in this, which one is the input layer and which is the output layer? First one automatically comes as input. Last one is completely output. Automatically output. No, sir, this is hidden layer, sir. Then hidden layer means inside only you have to keep. This is output layer, sir. This is hidden layer means then you have to bring the output layer outside, which is the last one. Automatically that is output. Last is output by default. Fix. And connect them. Connect like this. Total 6 connections you are going to get and create some weights initializer with respect to uniform and give the activation function as ReLU. Similarly, this one also uniform ReLU, uniform ReLU. Okay. For example, it is a binary classification problem. What will change? Instead of output activation function ReLU, you will change to sigmoid. I accept that. Remaining everything will stay. Remaining everything is same. Hidden layers, we are not going to change the weights. Weights, we are not going to change. ReLU activation function will not touch. Nothing will touch. In the output layer, we'll go with the sigmoid if it is a binary classification. Only change the output layer, output one. Don't touch the hidden layers. Always go with the hidden layers with ReLU. Best option is ReLU. But there is no rule. Sir, you are only saying best option ReLU and you are only saying no rule. Everything you are only saying. Why you are confusing like this, sir? Actually, I don't want to confuse you. Simply, I want to say, I want to show you only one activation function, which are step function. Step function will never use. Leaky ReLU will never use. And tanh function will use, but not in the ANN. It will be used in the RNN. Here, these both are not used. Since it is not used, I can simply remove also. But the problem is, in the interview, they may ask you. In an interview, they may ask you. Similarly, this is not important, I know. Similarly, coming to the weights initialization, uniform is the best one. Remaining, we will not use much. But I can explain only one thing. Just to simply take the weights between -1 to number of input neurons to +1 by input neurons. Simply, I can say this one, right? So that it will be easy for you to remember also. But the problem is, in the interview, they'll ask what are the different types are there. If I skip off that one, you may not answer that interview questions. Right? That is the reason I'm explaining those things also. At the same time, I'm saying which is in the real life, which is more important because you should not get any kind of overfitting problem. Both the things I'm covering. That interview questions I'm covering, at the same time, real life scenarios I'm covering. Two things I'm covering simultaneously. Right? Simply, I can skip off remaining things. Directly, I can show you that ReLU is the best one, this one directly. Whichever is important, directly I can shift into that one only. But in interview, they'll ask all the things. Right? They'll ask why we are not going to select the Leaky ReLU. They'll ask. Rikileru was first invented first Relu or Rikileru? Rikileru was invented first. I don't know here, but first it is invented. That is clear. First, this was only invented. First invented is Relu. Later, they have invented leaky. When they have invented latest one, for obviously latest one should be best, right? But here the problem is old one is only the best. What is the why means this is getting the overfitting problem. Because then if it is overfitting problem, then why have they have created, sir? Some people wants with respect to all the neurons to be active. All the neurons to be active means Rikileru. All the neurons no need to active means with respect to Relu. In the Relu, some of the neurons will die because the output is going to be 0. Some neurons output will be 0. Some neurons will die. But advantage is it will reduce the overfitting. Disadvantage is neurons will die. That is the disadvantage. One scientist has invented Relu, completed. One more scientist has got it out. Hey, you have invented Relu, but in your Relu, some neurons are dying. Yes, dying. Obviously, the neurons are dying. Unimportant neurons are dying. Now, the scientist has, whatever the other scientist is there, he asked that question. No, I don't want the neurons to be died. If neurons are dying means, what is the use of creating the neurons? Right? He has asked like that. Now, then he has created that one and he has invented. What they have invented without dying the neurons, Rikileru. After inventing the Rikileru, they have observed overfitting problem. One advantage is there, means other disadvantage is there. For everything, advantage is there, disadvantage is there. Any example, for any activation function, advantages are there, disadvantages are there. Out of which is having more advantages, that one only we are going to select. Right? So Apple phone is there, Samsung phone is there. Samsung is having Samsung advantages, Apple phone is having Apple advantages. Apple phone with respect to iOS is very nice. Security wise, it is very nice. And individual wise, very nice. But if you want to play if you want to install new apps or something, it will not allow. Whereas Android apps are more number of Android apps are there. More number of Android apps are there. This is the advantage of this one. At the same time, this if you go with the second one like Android apps, along with this is having the one more disadvantage is if you have got any repair, the service charges will be very high. Whatever the showrooms are there, including the Apple showroom or whatever the normal showroom. If you go to the normal shop and if you show iPhone also, minimum charge is 1,000 rupees. They will not even say, just they touch the phone and they clean also, they will ask 500 rupees. Just they apply the cleaning, whatever the cleaning solution. If they clean neatly and if they give also 500 rupees minimum, they will charge. If you go with Nokia means, they will charge 50 rupees. Cleaning is same. Cleaning is same. Cleaning solution is same. Keeping the buds is same. Everything is same. But maintenance is very high. This disadvantage is there, right? That is service charges is high. Initial price is very high for purchasing. It is having certain disadvantages. This is having, at the same time, this is also having certain disadvantages. If all advantages are with Samsung, everyone will buy Samsung. If all advantages are with Apple, everyone will buy Apple only. Why Samsung also will be there in the market? Right? So just based upon the requirement, based upon your requirement, whichever you feel is as best one, select according to that. Okay. If your requirement is camera only is the top priority, neither Apple, neither with respect to Samsung, go with Google Pixel. This is ultimate in camera department. So for this 12 megapixel and for this also 12 megapixel, it will do the more because all the images in the backend works on the TensorFlow, which was the Google's own product. TensorFlow is the Google product. Using the TensorFlow only, image stabilization or image optimization or image blurriness or image modifications is done. Everything based on the TensorFlow only. TensorFlow is one product of Google. So they have to, Apple also have to use Google's only in the backend for optimization purpose. Okay. So everyone are having their own advantages. Everyone are having their own disadvantages comparatively. Google Pixel is having only advantage with respect to camera. Apart from that, nothing. Remaining part is everything is low. But whereas when compared to Apple and Google, whereas Google Pixel, what is the Google Pixel Pro 7? We are having Google Pixel 7 Pro as of now in the mobiles, and Apple iPhone with 14 Pro. 14 series is running, and we'll get in the June 15th series, right? So whatever the Apple iPhone is there, this Apple iPhone 14 Pro and 7 Pro, out of these two sales wise, if you see cost, let us forget about the cost. Cost is Google only low, Apple high, very high comparatively. But still, Apple sales are very high in the worldwide or in India also, even in India also. At least out of 100, we can find at least 2 members in Apple. Out of 1,000, we'll find 1 person in Google. In this class, minimum, if I ask the students, at least one will rise with the Apple phone. Minimum guarantee. Okay, don't rise, example only. Minimum. But if I ask the same Google Pixel, none of them will rise. Very rarely they will rise. Samsung, no, Samsung means MI. Now latest is MI or Realme or Oppo, Vivo. So many things has come into market, right? Done. So everyone are having advantages. Every activation function has its own advantage. Every activation function is having its own disadvantage. Now, how it is going to work? Okay, once the activation functions are completed, now once the neural network design is completed, now I'm fitting the data. When I fit the data, now what happens? Till now, what we have seen is how to create the neural network only we have seen. Now, once we fit the data, calculation, now calculation starts. Okay, once we send the data now inside this one, for example, here we are having with respect to a house. In this house, we are having the input features like area, number of bedrooms, city, distance from the city, okay, and age. These are the 4 input features we are having, and output feature is price. We are having output feature is called as price. Now we are having W1, W2, W3, W4. 4 weights you are going to initialize, and you are going to calculate W1 x1 plus W2 x2 plus W3 x3 plus W4 x4 plus B and activation function, whatever the activation function. Since this is the prediction of house price, automatically it is a regression problem. So activation function should be ReLU only. Okay, we have to go with the ReLU only, right? Now the same thing, this is perceptron model. If you go with a neural network, again you are going to connect and you are going to predict the price. Where this neural network of one hidden layer with 5 neurons I have selected, and finally you are going to predict the price, right? Again, this one is going to add the whatever the neurons has been connected. Whichever the neurons has got connected, that one it is going to add. Whichever the neurons has not connected, that one it is not going to add. So in this, if you observe, this particular neuron was connected only with this one and this one. Sir, what happened with X2 and X4? It might be dropped. Dead neurons, whatever the it is 0, output is 0 means that connection will be automatically dropped, right? So in order to reduce the overfitting problem, in order to reduce overfitting problem in artificial intelligence, that is neural networks, in the neural networks also we'll get the overfitting problem. How to reduce that overfitting problem is, one is called as a ReLU activation function. Select the ReLU activation functions in your hidden layer. It will reduce the overfitting problem. That is the first one. Second one, there is called as dropout. Dropout means drop randomly some connections. Instead of connecting everything, instead of connecting to everything, drop some of the connections. Drop connections, some of connections. Don't connect everything. Example, like for example, I want to declare the holidays for Pongal holidays. Now, if I ask each and every student, one student will ask from tomorrow only. One student will ask from day after tomorrow. One student will ask, sir, after the holidays, 17th is Tuesday, sir. We can't start from Tuesday. Our parents are not allowing. So we'll start on Wednesday and we'll reach on 19th. Start on 19th. Don't start the classes on 18th. One student will say, sir, 18th and 19th also we are not getting the tickets. Directly start on 23rd only. We can't book the tickets. Train tickets are full. Bus tickets are full. Nothing which is available. So directly you start from Monday only. So If I ask the students, each and every student, each student will have some requirements. If I can't satisfy all the students, unless if I give the holidays from 16th, sorry, not from 12th to 20th, if I give only, everyone will be satisfied. Everyone requirement will be satisfied. Out of which some of the students don't require these many holidays. If possible, even Pongal holidays also, they want the classes. There might be some students who want immediately the job in the next immediately. So don't waste the time for holidays. Some people will be there, right? If I select all the students, I can't satisfy them. Instead of them, if I go with the sample of certain students, if I want to satisfy, what happens for satisfying all the students, overfitting problem will come. Means more number of holidays will come into picture. So then what we have to do is, we have to ask only certain less number of students. And whoever other students are not able to attend the classes, for them we have to share the Zoom link and at least attend the online. That is the alternate we can give for the other students, right? In order to reduce the overfitting problem. Same thing. Dropout also same. Instead of having all the connections, if all the connections are making with respect to overfitting, drop some of them. How we are going to drop? Not partial bias, with random. Randomly you drop them. Randomly drop some of them, which is called as dropout. Third option is L1 and L2, regularization. These are the three different options we are having. Three different options we are having. Regularization, automatically everyone knows what is meant by regularization. L1 and lasso ridge regularization. Right? Apply the lasso and apply the ridge. One is dropout, one is rail. Right? So just we are going to select as per the situation. Right? I will show you all of them one by one. In the coding part, I will show you if there is an output I'm getting with a overfitted problem, then how we are going to reduce that overfitting problem and how you have to select the dropout. I will show you everything, right? Every option I will show you. Next, how these neural networks will learn. Now, when you have fitted the data, how they will learn means, once you have given the values of weights, you are going to send the information. So let us take like this. Okay. TV, radio, newspaper, perceptron model. Let us create the perceptron model and I'll explain in a simple way. W1, W2, W3. W1, W2, W3. And for this neuron, sigma Wi xi plus B and activation function is automatically ReLU. ReLU is the activation function. In the first step, it is going to do sigma W xi plus B. Second step, it is applying the activation function, which is nothing but ReLU is the activation function. Now, W1, I'm going to give the certain value called as 0.03. This one, I'm giving the value as 0.09. This one, minus 0.10. Okay, some random values I have given. You know already how to select the values. Within that only it has to be selected. Initial values I have got like this, assume. These are the three initial values. First, 2,30,100, 37,800, 69,200 will be sent into this. First record information will be sent into this. What are the input values of three input values will be sent into this, and 2,30,100 into this value will be calculated, plus 3,37,800 into 0.09, plus minus of 0.10 into 69,200. It is going to calculate first sigma I Wi. That is nothing but 0.03 into 2,30,100 plus 0.09 into 37,800 plus minus of 0.1 into 69,200. First it will calculate this one. And bias. Some bias randomly initialized. Assume that bias was randomly initialized is 0. Assume initially 0. For our easiness, calculation only I am saying. Now, once it is calculated, some value it will calculate. After calculating, if the value is a positive value, assume that positive value I have got approximately 18,000 is the answer I have got. Whatever the answer I have got here, it is 18,000. It will write that one here, 18,000. Next, it will send the second record. What are the second record is there? Second record values, 44,500, 39,300, 45,100. Weights also will be the same. Weights will not change. And again, it is going to predict the value. Some value it is going to get like 10,900. It will write that one. Next, it will send the third record. It will predict the value. Fourth record, predict the value. Fifth record, predict the value. Sixth record, predict the value. Like this for all the records, it will predict the values. Now, you are going to have the Y hat. For each and every record, Y hat is there. How many records it will do like that? Whatever the number of records you have given in the X train, Y train, those many number of records. In the X train, for example, for this data set, 200 records are there. Out of 200 records, you have used 80% for your training. That is 160 records. Now 160 predicted answers will be there. Now 160 predicted answers, once it is calculated, now what it is going to do? Sigma of Y minus Y hat O square. That is sum of the squares of errors will be calculated. Once the sum of the squares of errors is calculated, now what it is going to do? It is going to adjust the weights. It will come back again. It will come back again. Again, it will adjust the weight, this one to some value, this one to some value, this one to some other value. Again, it will recalculate again from the starting. Again, it will adjust the weights. Again, it will do the starting. Again, readjust the weights. Again, it will do. Again, it will readjust the weights. Again, it will do. Like this, how many times it will do means, how many times you have written that many number of times. Each time it is doing is called as iteration. It is also called as epoch. Epoch or iteration, both are same. Epoch or iteration. Iteration means calculating the entire thing and calculating SSC value. SSC or MSC, whatever the error value you want. If you calculate SSC is low means automatically MSC is low. MSC is low means RMSC is automatically low. Everything are the same, right? Now here, if you are calculating your MSC value, let us assume you are calculating your MSC value. For first weights, it is going to calculate the MSC. Again, it will come back. Again, it will calculate MSC. Again, it will come back. For example, I have given the epochs is equal to 100. 100 times it is going to do the same thing. For example, I have given 1000. 1000 times it will do the same thing. 1000 times it will adjust the weights. Epoch of 1 means only one time the weights will be adjusted. Epoch is equal to means 2 times the weight will be adjusted. 1000 means 1000 times the weight will be adjusted. Now, once the weights are adjusted, finally, how these weights are getting adjusted? How? It from, for example, 0.032, directly it will not go to 0.09, right? How it is going to adjust the weights? How it is going to select the adjusting the weights means it is again depend upon the whatever the activation function you are selecting here. And it is applying the differentiation on the activation function. Whatever the equation is there, for that it is going to apply the differentiation and it is going to adjust the weights. So the same thing here, just observe. So first it is going to calculate the sigma WXI plus B for that activation function and it will give the output, certain output. And original value are having. Now, once it is calculated, the original value it is having and predicted value is there. Predicted value and original value, both of them are there. It is going to check predicted value and the original value and the difference between these two, which is nothing but the mean square error. First, it will calculate the mean square error. This mean square error value should be low. Again, it will come back and readjust the weights. It will come back and readjust the weights. The weights are adjusted in such a way that your overall, the loss, whatever the loss function is there, that should be minimum. Overall loss function should be minimum. See, for example, here I'm having a small data set. Total 8 records are there. These 8 records I'm using for training purpose. These 8 records I'm using for training purpose. Forget about the test records. These 8 records I'm using for training purpose. Now, first it is going to take the first record. For the first record, it is calculating the predicted Y. Second record, predicted Y. Third record, predicted Y. Fourth record, fifth record. Like this for all the records, 8 predicted values it is going to do. For each record, the original Y also is there. Now it is going to calculate the MSC, that is mean square error value will be calculated. MSC or SSC, whatever it is. Error it is going to calculate and it will adjust the weights in such a way that finally your loss should be minimum. And finally, finally with what value you are getting the minimum value, that weights will be fixed. That weights will be fixed. Now it will stop the model. Whatever the last step is there, that is the best model. That best model is always once it is fixed. For example, TV, radio, newspaper, and this one. I have given 100 epochs. Epochs are done. 100 epochs are done. And finally, I have got the W1 as 0.3.2. W2 is equal to 5.8. W3 is equal to 9.4. Something I have got. Now, what is the final equation is? Y hat is equal to 3.2 into TV, 5.8 into radio, 9.4 into newspaper. On the test data, whatever the test data or future data, just you have to substitute that values here and you are going to predict your answer. How you have done in the linear regression, that beta naught plus beta 1 plus beta 2, beta 3, how you have calculated, that is the max. Here, step-by-step process. Is it clear now? How the neural networks works? Here, the most important concept is there. Concept is called as loss function, cost function. Two functions are there. Loss and cost. What is meant by loss function? For each and every record, one error will be there, right? For example, you are having 5 records are there. For each record, original Y will be there. Predicted by also will be there. Five predicted answers also there. For each record, one error will be there. For each record, error is there. This record error is called as loss function. That is the loss. Error means nothing but loss. Each record, the error is called as loss function. Overall records error is called as cost function. Single record error. For each single record, error of single record is called as loss function. Error of overall records. Overall records means nothing but MSE. Mean square error. Overall means mean, right? We have to go with the mean. So overall, whatever the overall records, error of the overall records is called as cost function. That is nothing but MSE or RMSE, whatever it is, or SSC. These three of them are overall. For overall, you are going to calculate, not for single record. Sum is overall, right? Mean means overall. Overall summation of all the records divided by total number of records. Right? It is not for individual. Individual error is called as loss function. Overall records, it is called as cost function. Done? So now the neural networks are designed in such a way, the overall error should be minimum. Is that clear? Now, in the back end, it is going to take with respect to based on the gradient descent algorithm. Now it is going to work based on the gradient descent algorithm. Now what is gradient descent? Gradually decreasing the error. Gradient descent means gradually decreasing the error. One by one, slowly decreasing the error. Is that clear? Done? Now, let us explain with a simple example. 2x plus 5 is equal to 10. Now, what is the x value? You are going to say x value is equal to 2x is equal to 10 minus 5, which is nothing but 5. X is equal to 5 by 2, which is 2.5. Without using this one, tell me how to calculate x value. Without doing this type of max, what is the other option I am having? X value. I want not the minimum value, x value. Exact x value I want, not the minimum value. Minimum value means differentiation. Differentiation we are going to apply to get the minimum value. I don't want the minimum value of this. I want the exact value of x. What is the other option? Exactly. Trial and error. Try with different X values and substitute and see, which is called as trial and error. Right? Now, first, I'm going to initialize. So instead of X, for your easiness, I'm taking 2W plus 5. I'm initializing the weight with starting value. What is the general value, maximum value you can initialize? It can't be more than right hand part, right? It can't be more than that. The initialization I have done with 10, assume. That is the initial weight I have initialized. Wrong initialization or right initialization, whatever it is, some initialized, I have initialized. Now, first I am going to calculate the predicted hat, y hat. Y hat is equal to 2 into 10 plus 5, which is 25. Okay. So predicted y, I am initializing the weight is equal to 10. Predicted y, I have got 25. Now, what is the original y? 10 only, the original answer. Now, what is the difference? Minus 15. Y minus y hat, minus 15. Now, what is the square? Y minus y hat whole square is 15. And square root of that is, because here the RMSE, how to calculate MSE or RMSE? MSE is, what is MSE? MSE is nothing but y minus y hat whole square, sum divided by n. Sum is here, only one record is there. For that one record, only one sum will be there. N also one only. So MSE is equal to, for one record, MSE also, this is only MSE. SSE also this one only, MSE also this one only. And the square root of this one means this will be cancelled. Automatically you'll get y minus y hat only. This is RMSE. For one record, everything is same. There is no problem. Multiple records are there means you have to do the sum. Now, first I have got the error as minus 15. This is my loss function. This is my cost function also, because for one record, loss and cost will be the same. Multiple records are there, only cost function will come into picture. Right? Now, I have got minus 15. Now, what I'm going to do, I'm going to adjust my weights. Based on the error, I'm going to adjust the weight. Weight, I'm going to consider as 11. 2 into 11 plus 5, 27. And original answer is 10. I got error as minus 17. Means, as the weight increased, my change in the error was increasing, which I want decrease in the error. Means I have to go with the less weights. From this, I will confirm that one. Maybe, for example, I have initialized the weight as 9 only. For example, weight is initialized and the weight decreases, y is decreasing, means I have done correctly. I will continue in the same pattern. If I went in the wrong pattern, I will change the pattern immediately. If I started with a wrong way, miss, I will rectify that one. If I started in a right way, miss, I will continue with the same thing. Okay. So now here, it is understanding that, okay, as the weight increases, error is increasing. I want error to be decreased. So weight will be decreased. Now the weight I am changing to 9, which is 9 means 2 into 9, that is 18 plus 5, which is 23. Original value is 10. Difference is minus 13. Okay, error is decreasing. Means I'm doing the right way. Continue in the same way. Decrease the weight. W is equal to 8. W is equal to 8 means now 2 into 8, 16 plus 5, 21. Original value is 10 minus 11. Now I have to decrease the weight or increase the weight? How you have decided that you have to decrease the weight? Based on the error difference. Based on error difference, you have decided that weight has to be decreased. This is called as back propagation. The adjusting the weights based on the error. The weights will be adjusted in such a way that if the difference is increasing, for example, suddenly that difference I have got 15, then what I am going to do? I am going to increase the weight. By decreasing, I have got this one means I will increase the weight. Opposite I will do. Right? Now, since the error also decreasing, the weight also I am going to decrease. I will decrease the weight to 7. Next, I will get with respect to 19, 10. Answer is minus 9. Now, what I have to do? Decrease or increase? Decrease. 6. Next, 5. Next, 4. Next, 3. 3, 4. For 4, I am going to do 4. 2 into 4 plus 3, 13. 13 and 10. Here I am going to get minus 3. This is 11, 10, minus 1. Now I have to decrease or increase? Weight decrease, as the weight decreases, error decreases. So now I have to continue in the same manner, means weight decrease or increase? Decrease only. So the weight is equal to 2 I'm going to do. Now what happens? 2 into 2 plus 5, 9, 10 plus 1. Now what I have to do? Weight you have to increase. Between 2 and 2.3, you have to try with 2.1, 2.2, 2.3, 2.4, 2.5. Okay, answer 0 means stop there. Each one is called as iteration, which is nothing but epoch. Is that clear now? Is that clear? So every value it is going to apply and it is going to check the error. Based on that, it will move again backside and adjust the weights. Again, it will forward, again backward, forward, backward, forward, backward. Multiple times forward propagation, multiple times backward propagation. Forward propagation means calculating Wi xi plus b, and after that applying the activation function over that is called as forward propagation. Adjusting the weights is called as backward propagation. Rechanging the weights is called as back propagation. Is that clear? So now here the epochs, whatever the epochs I have taken this, if the weights are 1, 1, 1 change, okay. For example, instead of 1, if I go with 9.99, 9.98, 9.97, when I will get 2.5? Between 9 and 10 only, you are, between 10 and 9 only, you are having 100 iterations. Between 10 and 9, you are having 100 iterations. If you go with 9.99, 9.98, 9.97, means to get 9 only 100 iterations it will take. From there, it has to go to 2.5, means for 750 iterations it will take. After 750 iteration only, you will get the exact answer of 2.5. If you do this change in the delta, the change in weight is very low, miss. If the change in weight is very, very, very low, then it is called as vanishing gradient problem. What is meant by vanishing gradient? Means the change in weight is very low. If the change in weight is very low, change in error also is very low. That is called as vanishing gradient. Vanishing means there is no change. Vanishing means no change. Gradient means in error. No change in error. There will be no much change in the error. With that value of change in the weight, there will be no change in the error. So the weights has to be adjusted in such a way. It has to be adjusted in such a way that proper adjustment has to be done. Right? Exactly. Trial and error method. We have to take randomly some x values and we have to apply. The same thing will be applied in the deep learning. Initially, it is going to take the randomly some weight and it will adjust. And finally, it will get the correct answer. Because no one knows the correct answer directly. Sir, 2x plus 5 is equal to 10. You know x is equal to 2.5. Now, why you have to do? For simple example, simple only. It will give in just in second only answer. But for complex examples, where you can't do the mathematical, some equations will be there. In that case, what you are going to do? We are going to apply trial and error method, right? In the real life also, we are going to apply trial and error method only. Some complex examples are there. For example, e to the power of minus 2x plus log x plus 2 by x square plus 4 divided by x is equal to 20. Now, what is the x value? For this example, try x value. 2x plus 5 is equal to 10 means x is equal to 2.5. Easily you have to learn. Now you do the max for this without doing the trial and error. Tell me the answer. Without applying trial and error, try. Don't apply the trial and error. Now, some situations will be there where we have to apply the trial and error also in the max also. Some situations will be there. Easy calculations will be there. Both are not same. This example and this example are not same. How you can consider both as same type of example, right? So in this situation, we have got very fast limits. In this situation, it will take time. Here I have taken this one only. For example, assume 10 are there, 20 are there, 20 pluses or 20 minuses or 20 in between into is there something. Then if you do normal max means the God should come down. Right? Some situations will be there where we have to give the trial and error. In that situation, we have to apply the trial and error. Even in IIT also, this type of questions are there means option A will fix the value and option B, option C, option D, and we'll tick mark which is the best answer. We can't do the max there also. Shortcut is we have to apply what are the multiple choice they have given. Each option we have to fit substitute that values. Right? Done? Is that clear, guys? So we have to adjust the weights such a way that overall error should be minimum. So just it is going to apply. Now the gradient descent algorithm, it is going to process this one and it will identify the least value. So for example, here it is having these many weights are there. Deep neural network. All the times, all the weights will be adjusted. One epoch will adjust all the weights. These weights, these weights, these weights, these weights. Every weight has to be adjusted from the starting to ending. So here almost 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 8 into 9, which is nothing but 72. 72 weights has to be adjusted. Here 9 into 9, 81. Here 9 into 9, 81. Here 9 into 4, 36. So 72 plus 81 plus 81 plus 36, which is nothing but 10, 24, 27. 270 weights has to be adjusted. For one epoch, 270 weights has to be adjusted. Okay, first it will calculate all the forward direction and finally it will predict the output. And this output it will compare to the original one. And according to that, it will calculate the error and again come back and 270 weights will be adjusted. After adjusting 270 weights, again it will start from the starting. Again it will calculate. Again it will adjust. Every time forward, backward, forward, backward, forward, backward. So obviously it will take somewhat more time. Okay. So if normal systems, if you are working means they will die. So for this type of for these special systems we require. So special systems means everyone will not have the special systems. So then what they have to do? How they have created separately for XGBoost separate library. They have created for deep learning a separate library called as Keras. They came with a solution called as Keras, which will do the processing very fast. Comparatively in machine learning it will do. But it depends upon the total weights. If you are giving heavy weights means automatically this one also will take time. But normal weights means very fast it will do. When compared to normal sklearn, Keras is 10 times faster. 10 times faster than Keras. Sorry, sklearn. Keras is 10 times faster than sklearn in the time wise. But still it will also take more time means Keras, if you do the same thing in sklearn, it will die. So that is the reason we have created a separate library called as Keras. So few years back, that is 10 years back, we are not even having the Keras library. We used to work on the TensorFlow. Only TensorFlow. Directly we have to learn the TensorFlow separately and we only have to create the neurons. Manually we have to create the neurons. Neurons also we have to write and we have to make everything. Now, and at that time the lengthy code used to be there. For model only, to create the model. So for example, this model is there. Whatever the model you are seeing as of now on the image, for this model, at least you have to write between 60 to 70 lines of code for creating this neural network. But using the Keras, we are going to create 1, 2, 3, 4, 5. Just 5 lines of code we are going to use. In 5 lines will be, this neural network will be designed. In 1 line, these 2 will be completed. 1 line, this one will be completed. 1 line, this one will be completed. In 1 line, this one will be completed. 5th line with respect to the, whatever the compiler is there, that one. That is the 5th line. How many number of layers are there? That many plus 1. That many lines is sufficient. Without Keras, if you do miss, it will take at least 60 to 70 lines earlier. But now Keras is it was made the coding very dead easy. The coding of ANN also very easy. Coding is nothing, right? Now here, whatever the neural network is there, here total 25 weights are there. 4 into 5, 20, 5 into 1, 5. Total 20 plus 5, 25 weights has to be updated every time. And if you select any drop function, some of the things will be dropped. Otherwise, everything are connected means everything. Some of the things you have dropped, use a drop in order to reduce the overfitting. Some of them will be dropped randomly. Now, gradient descent means identifying the minimum value. Every time you are going to go with the error, slowly error, you are going to adjust. Finally, you will get the minimum value. Identifying the minimum error for the given equation, identifying the minimum error is by using the gradient descent algorithm. Gradually decreasing the error and finding the minimum error. Now, question mark. Again, question mark is there. Sir, in the minimum, two minimums are there. One person has invented gradient descent. Scientist has invented in particular year. Assume that year is 2000. Assume. I don't know. Example on. Okay. Here GK is not important for me, so I don't remember all these things. So assume that he has invented in the year of 2000 gradient descent. Now one more person has came with this question that, for example, I'm having the this kind. Now you are initializing the weights randomly. You are initializing the weight. Assume here you have initialized the weight. Based on your weights, the weight will be adjusted and it will move on to the forward. So negative suddenly forward means, for example, earlier we got the minus 10, minus 11 and minus 9. Okay, minus 7, minus 5. Like this we have got. Suddenly we have got plus 1, 2, minus 1. Now in between only our answer is there. Again we have adjusted. Suddenly from minus 2, again we have went to the plus 1. Weights we have increased. Do you remember in earlier example 2x plus 5? First we have came with the W is equal to 10 to up to 3. After 3, 2. From 2 again we have started increasing. Till that we have decreased the weights. Suddenly we have started increasing the weights. Now here also decrease the weights. Automatically if the error is getting positive miss, again you are decreasing the weights and finally you are getting the minimum value. This is the minimum. If the weight was initialized here miss, the minimum value is this one. If the weight was initialized here miss, after that it will go this side and this is the minimum value. If the weight was initialized here miss, this is the minimum value. If the weight was initialized here miss, this is the minimum value. It depends upon the wherever the weight was initialized. Where the weight was initialized. But this is called as minimum value. 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 Everyone are minimum only. Example, state first rank. I have got state first rank. If someone says only one person is there, state first rank. Within Telangana, one person is there. Within Andhra, one person is there. Within Assam, one person is there. Within Arunachal Pradesh, one person. Within Delhi, one person. Within Tamil Nadu, one person. For every state, state ranker will be there. Everyone are state first only. For every state, state first ranker is there. But overall out of these one, which is the best one? All India first ranker. Within the state rankers, state first rankers, all the state first rankers are having the lowest error only, right? State first rank means what is the meaning? Lowest error. He is having the error is very low. He is having the lowest error. He is having the lowest error in that state. In that state, he is the lowest. But overall, I want overall. Overall, who is the lowest means I have to observe all the state rankers, and within that, who is the lowest? That person is called as All India ranker, right? Similarly, this every person lowest error is called as local minima. Local minima can be multiple, but global minima will be only one. That is the difference between local minimum versus global minimum value. Right? So I want the global minima, not the local minima. Then what I have to do in order to calculate? For example, whatever the batches, let us take a simple example. Instead of going with a complex example, let us go still more simple example. I'm having multiple batches. Morning 9 a.m., 10:30, and evening 7:30. In each batch, the students' performance is nice. In each batch, I have conducted the mock interviews. From this 7:30 batch, one student is doing very nicely, top. He is the best. Within this batch, one student is best. Within this batch, one student out of Out of the students, he is the best. Finally. Now, whatever the best students, 3 are there. Now, 3 are the best students for their batches. Now, overall, who is best? Someone will be there, right? Out of these 3, one person will be there. Now, you have to compare between these 3 only, not overall batch, you no need to take. Here 100 students are there, 100 students are there, 100 students are there. Means out of 100, 1 you have got. 100 students, 1 you have got. 100 students, 1 you got. Now you apply the test only between these 3 only. No need to go with again 300 students. If you want overall means don't select again 300. Just select only 1. These 3 between. So whatever the entire data is there, here the entire data instead of 300, who is the best you want means first divide the data into parts. 100 students, 100 students, 100 students. In this, identify who is the best. In this, identify who is the best. In this, identify who is the best. Out of these 3, again identify who is the finally best. Right? Within this 300 students, divide the data into 100. This is called as batch. Dividing the data is called as batch. Divide the data into batches. Within the each batch, identify who is the best. Identifying who is the best means identifying who is having the least error by applying the gradient descent algorithm. Now overall, who is the overall lowest? That is called as stochastic gradient descent. So stochastic gradient descent gives you the global minimum value. Gradient descent gives you the local minimum value. That is the problem in the gradient descent. So the problem in the gradient descent is gives you the local value. So it is going to identify like this. It will identify the minimum value here, but the minimum value is not here. The minimum value is here. Then how you can get means you have to go with the stochastic gradient descent. Now what is meant by stochastic gradient descent means, for example, this one is the data. First you divide the data into batch. In this particular batch, where is the minimum value is there? This one. In this batch, where is the minimum value? Here. In this batch, minimum value. In this batch, minimum value. In this batch, minimum value. Now, out of all of them, what is the minimum value? This one. Select. From each batch, you select the minimum values and overall select the overall minimum value, which is called as global minimum. This is called as local minimum, local minimum, local minimum, local. Local means within that batch. Within this particular part, this is the lowest. Within this one, this is the lowest. Within this one, this is the lowest. Within this. From each of them, that is the lowest one. I want overall lowest one, which is the stochastic gradient descent algorithm. Stochastic gradient descent means dividing the data into batches and identifying the global minimum value. Is that clear? That is the end of the ANN. Now we are going to see the coding part of ANN, that is in the tomorrow's class.